Okay, let me see here. Looks like we're good there. Let's pause the. This one's muted. Back here. It's gonna go away.
Check, 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 check. Still sound good? Is that the right microphone? Yeah. Why that was on the other one. Maybe put touch closer. There we go. Okay. Now we're jumping in. Picking up more or less where I left off on the previous stream. So if you end up watching this, if you're watching in the future or whatever, and you're interested in what I'm working on today, you can go back and watch the previous one if you didn't catch it. I did do a little bit actually in between. I think the previous stream was 2 days ago maybe, and I worked on it some last night while I was watching Show and Tell, and I did not stream it. So we're a little bit further along than we were, but I'm still working on the same thing, which is generating these sprite sheets of angled character digits, angled number digits to be specific. Let's see, we probably have something that will show a good example of this. Maybe this should. So this is the top half of a, I think it's a 3, but it might be a 2, I'm not sure. And it's meant to be like each frame, each sprite is a frame in an animation where that number and the little card that it's on are flipping forwards. They're kind of like folding themselves towards the viewer. And we're going to put this on CircuitPython. We're going to go through and animate all these things to make it look like that card is flopping down. And ultimately, we're trying to use this to make a flip clock widget. And so where I am at is I think I've got the correct top and bottom angles happening. Let's see, it's saving them called top half, but it is actually set to bottom half now. I got it broken out to where angled sprite set. Let's see, where is the breakdown actually? I got it broken down to where it's choosing. So there's 2 different functions now. I used to only have one of these, find coefficient inputs for angle. Now I have 2. One is bottom half, one is top half. They both do basically the same thing, which is take an angle, a number 0 through 90 essentially, and then spit out 2 planes, or the points that make up 2 planes that represent the corners of the perspective skew that we're going to apply to it. And the perspective skew used in the bottom half versus the top half is different. Now we have 2 of these functions. I did top half on stream the other night. Bottom half I did last night, and it was not on stream. So that gets you caught up if you are just joining in. I will run this, or let's open this folder, I guess. This should have the bottom ones, even though they have top in the name. Yeah, so these are the bottom ones, and these also flip down. So that's each frame in the animation, and I think this is the bottom half of a 3, and that's flipping down. So a couple things we need to do next. We need to be compiling these into sprite sheets, like this one back here that I showed, test BMP. This is made a sprite sheet that has 6 sprites in it. We need to basically be doing this. Which obviously one of the scripts I have is, this one is, or some of the code I have is, but we need to be doing it with both the top half sprites and the bottom half sprites, and then put them all into a sheet. And then ultimately we're going to want to do this for all the characters. Right now I'm just hard-coded the 3, but we'll make an outer for loop that's going to go over all the characters we want. So let's break out bottom half, top half. I think we need another argument here, like bottom skew equals, doesn't really matter by default, I guess, right? False. Let's just say false. So this is if bottom skew, else this is top skew. And it's pretty much the same. We can just use the other one of these. Now there's two of these. Now we can pass this in to tell it which one we want. Let's make sure that works. Bottom skew true. And we rename these to bottom half, so let's delete these, run it again, and see what it generates. Let me also use my pad here. I don't use this too much these days, but I do like it for the run hotkey. Maybe I should add a different one to my keyboard. This did spit out a bunch of bottom half things, and yeah, there we go. So, yeah. So, let's do both? Do both. Yeah, angled sprites. So, let's say this is bottom angled sprites. Say this is top angled sprites, which has bottom skew false. And now we want to loop over all of these. Okay, so now we should get all tops and bottoms saved out. Then after that, we want to pack them into a sprite sheet. So this does happen sometimes. I don't know if there's a F5 or yeah, F5 works. So we got bottom halves. Right now it's set on 10. That's the other thing. We can choose how many animation frames we want. So this one is putting out 10 animation frames total. And we'll play with it a bit to figure out what's a good balance between how big the sprite sheet has to be and how smooth the animation looks on the screen. I tried it the other day on the previous stream at 5 and 10 frames respectively. And 10 definitely looks smoother, but 5 I didn't think looked bad. But I think I'll try 10 and see how much space it takes up, and we can drop it back to 5 if we need to. Did some rough math calculations. I think we have plenty of room, truthfully, as long as you're not trying to like do too much with it. As long as we can reuse the sprite sheet too as well. That's one thing. Ultimately, we're going to want multiple tile grids that reference the same sprite sheet, and I'm not sure, but I'm hoping that's not going to cause the sprite sheet to be in memory multiple times. We may run into trouble in that case. But we'll cross that bridge when we get to the actual CircuitPython widget. I think we pretty much have, these are all looking right to me. So this is for the 3 top half sprites, bottom half sprites. All the animation frames are looking good. This one looks like, you know, it's falling forwards. It's getting closer to you. Falling down towards the middle. And then this one is also falling forwards, but it's falling from the midway point down. Whereas this one was vertical and fell down. This one is already horizontal. Flipping down, and yeah, the 3 skew of the yellow box, everything looks like that's flipping down. So let's make a function that will pack these into a sheet, because really what I have are lists of PIL image objects, we could make a generic function that will just take a list of PIL image objects and pack it into a sheet for us. Def pack images to sheet, takes images, which will be a list of images. I guess I could type annotate this. I haven't done much of it. So I have some code that's packing sheets, like here, make static sheet. Coordinates, this is roughly the logic. Let's say width. Width. And this is going to be the number of sprites in a row in the sprite sheet. Expression? What did I do wrong? Square brackets? Ah, okay. This is actually width, and then this is... tile height. Image dot height. One thing is this will assume the images are all the same size, which in my case they are. So it's not like an efficient packing algorithm to pack different shapes together. It's just to make a big sheet out of the same size sprites. Definitely not supposed to be 3 here. I have 10 mod 3 for the X and 10 over 3 times the tile height. Oh, it's I over 3 actually. But I think this was making it have 3 rows. That's not what I want. I want dynamic. We don't know how many rows. The number of rows is based on the number of images and the width. Rows equals, actually let's say row count equals length of images divided by width. So if you have 10 images and you tell it width 3, you're gonna get 10 over 3. That's gonna round down to 3 though, isn't it? Really what we want would be 4. We can't just add 1 because then if it divided evenly, it wouldn't work right. Like if we had 12 and we told it width 3, then it would say 12 over 3, we'd get that to be 4, and then we'd plus 1 to be 5, and that would be wrong. We need to round it up if it has a decimal. I don't know How does math.round work? I think that exists, right? Or am I thinking Java? Round. It's not in math. Round. Number digits. I'm gonna read this real fast. Sorry, 1 second. Minute. Heather, it'll be a minute. So can we make it go up? Oh, that's called, this is not round, this is ceiling, right? Seal? Yeah, this is what we want. What we want. Make sure with the old REPL here. Math, or math. Math.seal. We just give it 3. Math has no seal. Spell it right. 3. But if we give it 3.1, that's what we want. Yeah. Actually just width, isn't it? For all of that is, I think it's actually just width and not row count. This would be how we calculate the row count, but the row count will figure itself out because of the count of this and the way that this math works out. I think we don't actually need that. We'll keep it for a minute and see if this works, but coordinates. So we need to make a full sheet image, full sheet like this. Call it sheet image, this one, underscore, internal to this. Make it, it's gonna be, oh, okay, here we go. Here's where we need the row count. Yeah, okay. Do this after this. And it's gonna be, say, width equals images 0 dot width height row height. Okay. This is width times width. Then this is height. And this is times row count. This is where we need the row count. Background color. At some point I'm going to figure out the colors somewhere, because really what I want is I want these to have like green or something that we can key off of in CircuitPython to make it transparent. Although the truth is well, I was gonna say black would work just as well, but that's not actually true, because we're gonna end up needing this to be layered over. Yeah, we're gonna need transparency, especially like where like this image has transparency here. We're gonna need that to get filled in with green or pink or some specific color that we can use inside CircuitPython. And I don't think we want it to be black, actually, because black could be used for the character. Really what we need to do is pick a different color that's not in use. Black is what happens by default, but maybe we can just like use green if it's not in use, and then if it is, use pink instead. Have one other backup in case they're both in use or something. I don't know why this is open. We don't really need this. That's our sheet. Once we get to here, we're gonna paste sheet image dot paste image at the location coordinates return sheet. So let's say both sheet equals pack images to sheet. List of images is bottom angled sprites plus top angled sprites. Doesn't that work right? Doesn't that happen when you add a list together? List plus yeah. Or you know what though? Well, we can use this to test. Yeah, I don't. I actually won't want these together. Thought about this last night. We want all the top half animations in one sheet and all the bottom half animations in a different sheet. That's what we want. Actually, I'll just give in bottom. We'll call this bot sheet. Call this bottom sheet. images. So this will give us back our sheet. We can then just try to save it, see if it worked. Bottom sheet dot save test bottom sheet dot png. I'll just save it as png. No, I'll save it as a bitmap. We need to do transform first, or not transform. It's a convert. Oh, width. Width. Let's say. Right now we're doing 10. Just go 5, I think. That way we get 2 rows of 5. Or do we want a full row of 10? I don't know if it matters, like if it makes a difference whether the image is wider versus taller versus square. I don't know if any one of those or the other is better, or if they're all the same ultimately. Let's just go 10. That's width. I might as well put this in. Images. Bottom sheet. Oh. Bottom sheet. So this will make it to bitmap indexed. And we can save it this way. Or I guess this makes it indexed and then we can save it as a bitmap like this, but like that. So let's save this. Let's run it. Crashed. Parameters, generics, types must be types. That module. Okay, we did something wrong with our typing. Take this out for now. The right syntax for a list of image. I think it should be angled, but I thought I tried angled brackets and then it was broken. I don't know. Figure it out later. Bottom sheet. Ah, that's not good. Go here. Go print chords. Find our other prints and turn them off. This one actually we want on. Length images. Width. Width. Image width. Image height. See if these are making sense when they get printed out. This doesn't seem like the right number. Things here. I think we should have just got 10. And we just have another print somewhere. Length 10, width 10. 10 images, 10 width, image width 480, image height 50. That does all seem fine. The coordinates are definitely wrong though, because we are seeing it just be 43.2, 432, 432. I guess is 48 times 9 probably? Yeah. We don't have an I in here. We are still printing something else also. That looks better. Okay. Currency color. I'll just go green, and then like I said, eventually I'll make some logic that will change it if green is in use. I like using green because I think of it as green screen, which is just common color chroma key stuff. So when we pack it into this, I think probably makes good time to do that, because that's when we're going to be converting this to, actually that's outside of here, isn't it? Paste allow stuff to show through? It works like that. Color. Currency color? Gonna work? No. So let's just make sure. I can save it as bitmap at this point, maybe. Okay. That does have green in it, but when they get pasted, actually getting taken over with black, which I guess means that inside of these images they have save test. Turn these off for now. String. Black. If we just save them as PNG, do they have transparency though? Actually have black. Have transparency. Mm. Ones are transparent. So the transparency is like pasting. It's not pasting the full rectangle, including the transparency, not putting the transparency on top and letting whatever was below go through. Foreground. Image. Okay, that's what we're after. So now we would be able to make green transparent inside of our palette in CircuitPython. It wouldn't get drawn, which is going to be important because there's actually going to be something behind it. It's going to be covering something up, and we want that green to not get shown. Okay, so we don't need this stuff. We don't need this to save. Probably don't really need to do these. We don't really need to save that. We really just want the bitmap output. The rest of those we're just trying to figure out what was going on at various different stages. So now we are able to pack together a list of images. So we could go top sheet. Top angled sprites. Whoop. Oh. Nope. Images. Images. No. Image. Oh my. What have I done? There we go. Top angled sprites with 10. Okay. Pack images. Top sheet. Convert. Yep. Save it. Test. Top sheet. Save it. New line. Oops. Line. Save it. Goodness, please. There we go. So now we'll get 2 bitmaps, one for top, one for bottom. And that test bottom BMP, test top BMP. This one's top, and then I actually still have bottom over here. Just perfect. That's what we want right there. So really all we would need now is we want to get every character. This one's hard-coded to 3, but we want all of them, and so but this stuff all works. We have our pack thing working. I guess we don't know that it would work if we had more than 10. So we could go 5, I guess, right? That would test. We did 5 here. Okay. Yeah. That's right. That should work. I'm gonna put it back to 10. And now we just would need to generate all the rest of the characters and put them into these. So let's make a loop for, I guess let's make, should we make this a function? Have make static sheet, maybe we'll have make animation sheets. This is not JavaScript. Font size. Yeah. So this is basically gonna do all of this except for bottom sprites is a list, top sprites is a list. For I in range 10, f string I. And then instead of just having bottom angled sprites, top angled sprites, or I guess we could still do that, but what we want is bottom sprites dot extend bottom angled sprites, top sprites dot extend top angled sprites. So that's gonna add all the things in this list to this list. So now we'll just keep building it up. We'll get all the sprites for 0, then all the sprites for 1, then all the sprites for 2, 3, 4, all the way up to 9. They'll keep building up into these lists. And then at the end of all of that, we can do bottom sprites. Make animation sheets. Okay, so this should be inside some. We need to keep this. I'm gonna put this down here, but we may be close to being able to just delete that. But we should pass this. Bottom sprites, top sprites. Those are our big lists. Bottom animation sheet. Top animation. All right. Oh, we didn't call the function. Classic. Move it into a function and don't call it. All right, let's do that. There we go. Bottom animation sheet. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All bottom halves. 10 frames each. Be kind of curious. Does this turn out if we use transparency color where we currently have the blue? I think this might actually end up being how we want it without the blue in there as well. We can go both ways, obviously, because the script is easy to change, but let's look at top. Yeah. Okay. Those are the sheets we want. What else do I want to do tonight? So this is going to be the deep dive topic for tomorrow. So mostly what I want to do on deep dive is build the widget, CircuitPython object class. Couple layers of it I have in mind. The flip digit will represent a single character, and then I think we'll make a flip clock or something that represents two sets of 2 digits and a colon in between. It could be used as a clock, but we'll build it as a digit class that is self-contained and it can do its own thing, and then build the clock on top of that. That way somebody could reuse the digits and put them in different configurations instead of 2 and 2. But I do want to do that on the deep dive tomorrow so that folks can see the process of building a widget like that. I think what I could do though is are we making the static sheet right now? I think not, right? Oh, we are. Static sheet. So is that coming up with full sheet? We should call that static sheet. Static sheet. Yeah. This has no more blue as well, which is what I want. Okay. So let's take, well, first of all, let's get a look at how big are these things. What was it? It's bottom, bottom animation sheet, top animation sheet. Maybe we should do animation bottom and top animation first. So they go next to each other if it's alphabetical. So this is 480 by 500, and it is 241 kilobytes. I assume the other one is the same, I think, right? Yeah. Okay. Feather on the desk, plug it in. I don't have the camera, so nobody else will see it. I apologize. It's super cool, maybe I'll show it, but otherwise it'll be on Deep Dive tomorrow, so if you want to see how it looks, I encourage you to tune in to that. And not only will you get to see it on Deep Dive, we'll get to actually make it functional, whereas right now I'm actually, I think, just going to fake the animation a bit just to see how it looks. But we'll actually make the class out of it tomorrow that runs the animation as needed when you change the number in it. In order to fake it, we will basically just run through the, what will we do? We will open device workspace, first and foremost. We will create 2 tile grids, one for the top half, one for the bottom half. We will run the top half tile grid through a certain numbers animation. And then when that's done, we will run the bottom half tile grid through an animation, all the frames in an animation. We will need 2 sprite sheets, top sprite sheet, bottom sprite sheet. Top, probably these should actually be top, bottom animation sprite sheet, top animation palette. Oh. Animation sprite sheet, top animation palette. So 241K times 2 is about 500K. Plus the static, which is a little bit smaller, I think, right? That's only 58K. Yeah, 10 frames, we don't even have a meg. Using like maybe a quarter-ish of the total RAM, but I mean libraries and other stuff also take up and code and everything, so like just with the bitmaps, we're taking up about a quarter. And that's 10 animation frames. We could back it off to 5. I did set that up, and 5 looked alright to my eye, but 10 certainly looked smoother. I'm going to take static sheet, I'm going to take bottom animation sheet and top animation sheet, copy those, we're going to drop these on the device. Ran out of space. Probably. Anything paste? Static sheet pasted? The top and bottom did not. Uh-oh. IO exception couldn't copy. Get rid of that. Get rid of that. Get rid of that. How much space do we have? Is that right? Total capacity is only 963K? We have 500 of our 2 bitmaps. Not using BME, not using shapes, not using text, iter tools, not using MQTT, not this, not this, this, this. Here. Definitely don't need 2 copies of this. We probably don't need this at all, truthfully. These are old ones, but I'm for time. 700K open. This is a little tight. Maybe we want to back off at 10 a bit. 10 is a touch too much. Good old touch too much. See. Okay. So now we want 2 tile grids. Top tile grid. It is 1 by 1. Tile width. Yep, all that is right. This one is bottom. Uh-oh. Whoop. That's the same. We need to fix these. Bottom. No, top. Bottom. Tile grids. We don't want to put them like this anymore. Was putting it in the center vertically. We don't want that. Instead, we want just... I'm just going to leave top tile grid in the top left of the screen for now, and then bottom tile grid dot y is going to be equal to top tile grid dot tile height, which in my case is 50, but I want to code it this way instead of hard coding it in case it changes. There are variables inside the PIL script that let you choose the size of that, and ultimately it would turn out at a different size. Put that one below, make a group, append both. Current index, last animation time, show the main group. Okay. So we want bottom tile grid hidden to start. Seems to have, oh. Property. Bottom tile grid is hidden. If it's time for the animation, current index +1. Let's say running top animation equals true. Per index, this is actually 9 because we bumped it up to 10 animation frames. Resets it back to 0 times sleep, and also running top animation equals back to true. Oh. Okay, here's what we need is actually, yeah, set that to 0, and then if we were running the top animation, we don't want to sleep. We do want to set this to false. Else sleep. Okay, and then now here we go. If running top animation top tile grid 0 equals current index, else else running bottom mission, running top back to true. Bottom tile grid 0 per index. So I think this will go all the way through the animation frames on the top, then go all the way through the animation frames on the bottom, then sleep for 1 second. Okay, actually we need to go bottom tile grid hidden false, so that will get shown. And then I guess on the top, hide that there. If we ever need to hide the top, eventually we're going to be hiding the top, and we're going to actually be having the static one behind. For right now, though, I'm just going to run it like this and see what it does. Okay, I think that's pretty sweet. I need to, I do need to make the green transparent. One thing is I don't know the order of the palette. Hopefully green is already 0. That would be super convenient. Oh, there's actually a couple of greens though. Huh. Zero through 8 are greens. I wonder though, I don't know that we don't actually want that. I don't actually want that. I'm gonna run it this way for now because it should look mostly alright, but we don't really want our foreground, the yellow, to bleed into the green like this, because that makes it harder to do the transparency. Really what we want is the yellow to be hard cut. So like these should either be full yellow or not, right? They should either be full yellow or full green. Or they can be a darker yellow, but they shouldn't be. They could be darker, but they can't be like mixed with green. We don't want them to be partially mixed with green. They need to just be yellow so that we can hard cut that edge once we set green to be transparent. We probably need to just convert it to indexed earlier in the process. Or maybe not set green as the background before we do the 3D transform. Maybe if the background was just transparent before we did the 3D transform, could we then convert that to indexed and then paste it on top of the green? I don't know if that would actually work how I'm imagining. So I did reorder that. It didn't save. That's annoying. I have to delete this before I paste or save the other one. I don't think we have enough room. It's kind of 0 through 9. Oh, maybe it's not. I think those numbers get messed up. Actually, more like 0 through 6. This one's actually 1 through 6 also. I just read the numbers wrong. Darn that GIMP and its numbers being weird. Does that to you on the color map. So we got both of those. It's 0 through 6. Inside of our CodePy, I'm going to go for I in range 7 because that's going to give us 0 through 6. And then top animation palette dot make transparent I bottom make transparent. Palette object has no attribute. Make transparent. Make transparent. Transparent. There we go. Oh yeah. It's kind of slow, truthfully. Animation delay, we have 1/10 right now. So, well, that makes sense. Yeah, that would make the whole thing take 1 second. Right, twice as fast. I'm actually really surprised how smooth the animation comes out with the 10 frames. It's like, honestly, it really looks like it's rendering it live instead of just showing pre-rendered frames. That's pretty sweet. Curious how much faster we can actually get. That's a little bit, but not much. I think we're approaching the point where, like, can't actually make it any faster. I think we're, like, just going about the speed that the thing can update. Oh, no, we certainly can go slower. That's pretty fast. But it's very flip clocky for sure. There we go. That's probably the one. Eventually this will be settable, right? We'll make that configurable as part of the input. Okay, I'll tell you what. I'm gonna wrap it up here pretty soon. But I'll grab the camera here and I'll give you a look at it for the folks watching. And then, yeah, we'll do the class for it, the object tomorrow on Deep Dive. We'll code that up. I'm definitely liking it though. I think this flip action looks pretty good. We gotta still get the static one in the mix and got some other tricks to play, but crash. That's what we got. Let me move it over so it's not behind the tape. Or I'll be asked to take the tape off. For any real photos. Let's go. Why? There it is. Let's go. Tilegrid.x equals, I don't know, let's just go 100. So that's pretty good. So we'll have, like I said earlier, we'll have the static one behind it. So like right now the top half is disappearing, obviously. But the top half will stay there. Like, visually it will stay there. Technically it will go away, but there will be a static thing behind it that will look the same as what it needs to look like. That's quite a bit slower. Yeah, so the static will help it out. It's going kind of fast here. We might have one more little pixel of yellow in there that should have been transparent or something. The other thing is we'll probably be drawing a line through the center. I don't actually have a line through the center right now. But but actual flip clocks do. There will be probably like a black line, or maybe you can configure the color that will actually cut this in half. Because of course the way the flip clock works is top half, bottom half. But that won't, we'll just add, that should be super easy for us to do now that we've gotten this far. We should be able to just plop in a black rectangle that's a couple pixels tall right in the center there, and should be no biggie. Super easy. Which will probably get rid of that little 1 pixel yellow that we're seeing on the edges there as well. I'll have to try to figure out what to do about the green. I would like to hopefully not have to do multiple transparency colors if possible, but cross that bridge when we get to it. Yeah. Alright, I'm feeling pretty good about it. This is basically what I wanted to get through tonight, was spitting out the top half sprite sheet, the bottom half sprite sheet, and then just proof of concept, getting it onto the device and taking a look at what the animation actually looks like. So we've made it to there. I am gonna take off for the night. Thank you anybody who is watching. Again, you are interested in this project and you didn't catch the stream from, I think, about 2 days ago, you could go back and watch the VOD. That should still be on Twitch, or you could catch it on YouTube as well, indefinitely. That's where I worked on the first half of this, and if you want to, you can tune in tomorrow night for Deep Dive on the Adafruit channel, and I will work on writing the CircuitPython class that will make a nice, easy-to-use API for instantiating this and setting the character, setting the number you want it to show, and also having the static one in the back and all that stuff. So we'll build that class tomorrow night on Deep Dive. So thanks for watching. I'm gonna head out. Hope everybody has a good night, and I will catch you